Have you ever wondered what would happen if you fell into Jupiter? Imagine for a moment taking a hypothetical plunge into the vast, swirling atmosphere of Jupiter, the largest planet in our solar system. This giant gas planet, with its stunning bands of clouds and fierce storms including the famous Great Red Spot, is a world of extreme conditions unlike anything we experience on Earth. Jupiter, a massive sphere composed mostly of hydrogen and helium, plays a pivotal role in the solar system. Its immense gravity influences the orbits of other planets and helps protect the inner planets from potential comet and asteroid impacts. But what would this mean for a human-sized object descending into its depths? As we embark on this thought experiment, let's dive into the realm of imagination and science. We'll explore the layers of this colossal planet, each holding different mysteries and extreme environments. So, what does this mean for our imaginary plunge into this giant gas planet? First off, let's talk about the atmosphere you'd encounter on this descent. Imagine plunging into a world where air is nothing like what we breathe on Earth. Jupiter, the largest planet in our solar system, holds secrets in its atmosphere that are both fascinating and formidable. As you begin your hypothetical fall, the first thing you'd notice is that you're not falling through a typical atmosphere. You're diving into a thick soup predominantly made of hydrogen and helium. In fact, about 90% of Jupiter's atmosphere is hydrogen, the simplest and most abundant element in the universe. And nearly 10% is helium. This composition is quite reminiscent of the Sun and gives Jupiter its characteristic jovial volume. But the intrigue of Jupiter's atmosphere doesn't stop with hydrogen and helium. Lurking within this gaseous envelope are traces of ammonia, methane, and water vapor. Each of these components plays a crucial role in the planet's meteorology and has profound implications for any visitor. Ammonia, for instance, creates the white bands you might have seen in images of Jupiter. These bands are actually high-altitude clouds, thick and opaque, reflecting substantial amounts of sunlight. Methane, though present in much smaller amounts, absorbs sunlight, contributing to the warming of the upper atmosphere. And then there's water vapor, which, despite its lower concentration, suggests that Jupiter could host mechanisms of weather much like Earth's, including storms and possibly even rain, though not the kind you'd want to get caught in. As you descend deeper, the atmosphere becomes denser and darker. The pressure increases, and these gases, which at higher altitudes appeared almost serene, become wildly turbulent. Jupiter's fast rotation whips winds around the planet at speeds unimaginable on Earth, creating a chaotic environment that would challenge any notion of a peaceful descent. With this volatile mix, Jupiter's atmosphere is far from welcoming. This giant planet, cloaked in its thick, swirling gases, is a reminder of the wild diversity and sheer scale that our solar system holds. As you dive deeper, Jupiter's gravity would play a crucial role. Imagine Jupiter as a colossal giant in our solar system. Its mass is about 318 times that of Earth. This immense mass exerts a gravitational pull that is over 2.5 times greater than what you'd experience on our home planet. As you move closer to Jupiter's core, this pull grows exponentially stronger. The sensation would be unlike anything experienced on Earth. At first, the increase in gravity would be a novel feeling, almost exhilarating. But as you descend further, the reality of Jupiter's powerful embrace becomes more apparent and increasingly overwhelming. Consider this. If you weigh 150 pounds on Earth, on Jupiter you would feel like you weigh nearly 400 pounds. This intense gravitational force doesn't just affect your body weight. It influences every object around you, pulling them at a much faster rate than on Earth. Descending through the thick layers of clouds, the gravity would compress everything in its reach. This isn't just a simple increase in weight. The structure of materials, the behavior of gases, and even light itself would bend under the influence of this extreme gravitational force. This increase in gravity also speeds up the descent, pulling you faster and faster towards the center. Every moment spent falling into Jupiter increases the peril, as the gravitational force builds up to levels that are hard to comprehend. This intense gravity would make the descent increasingly perilous. Now imagine the pressure building as you fall deeper. As you descend into the vast expanse of Jupiter, you're not just falling through a sea of gas, you're plunging into an increasingly hostile environment where the atmospheric pressure skyrockets beyond anything experienced on Earth. Let's put this into perspective. At sea level on Earth, the atmospheric pressure is about 14.7 pounds per square inch. This is a comfortable, familiar pressure that all terrestrial life is adapted to. Now consider diving into the ocean. For every 33 feet you descend, the pressure increases by about another 14.7 pounds per square inch, due to the weight of the water above you. Now, back to our giant gas planet. As you fall through Jupiter's atmosphere, the pressure doesn't just increase, it explodes exponentially. At a point equivalent to just 100 miles below the cloud tops, the pressure is already a staggering 200 times greater than Earth's atmospheric pressure at sea level. Imagine going deeper, much deeper. The pressure soon becomes comparable to that found in the Mariana Trench, the deepest part of Earth's oceans, lying about 36,000 feet beneath the surface. Here on Earth, the pressure is an incredible 15,700 pounds per square inch. But on Jupiter, you haven't seen anything yet. As you continue to fall, you would encounter pressures so immense that they dwarf those of our deepest oceans. At these depths, the concept of pressure takes on a new meaning. It's not just a number, it's a relentless force that can crush metal like it's a soda can. The intense pressure would compress hydrogen into a metallic state, something that doesn't naturally occur on Earth. Under such extreme conditions, survival becomes unimaginable. The sheer force exerted by Jupiter's atmosphere would make it impossible for any known material or biology to maintain its structural integrity. The further you descend, the more you realize that Jupiter is less a planet and more a beautifully inhospitable abyss. It's not just pressure, the heat would be unbearable too. As one descends further into the gaseous abyss of Jupiter, the temperature begins a relentless ascent. Imagine plunging into a world where the heat isn't just a byproduct of solar warmth, but emerges from deeper, more turbulent processes. The primary source of this inferno is not from the sun, as one might expect, but from within Jupiter itself. This giant planet radiates more heat than it receives from the sun. The reason lies in its formation billions of years ago. As Jupiter formed, it captured a significant amount of the primordial dust and gas swirling around our young sun. The immense gravitational compression of this material released a prodigious amount of heat, some of which continues to drive the planet's internal engine today. Furthermore, the decay of radioactive elements within Jupiter also contributes to its internal heat, adding to the already sweltering conditions. As one nears the core, temperatures can soar to around 43,000 degrees Fahrenheit. To put that in perspective, this is over 7 times hotter than the surface of the sun. Such extreme temperatures mean that any earthly material would not just melt, it would vaporize instantly. This scorching environment adds another layer of hostility to Jupiter's already brutal conditions. So, what have we learned from our theoretical journey into Jupiter? Well, it's been a thrilling ride, to say the least, and one filled with enlightening, albeit harrowing, insights into what lies beyond our earthly confines. First and foremost, Jupiter's atmosphere is nothing short of hostile. We've navigated through layers of ammonia crystals and water droplets, each layer more unwelcoming than the last. These aren't mere rain showers, but rather tempests of chemicals that can dissolve much of what we know here on Earth. This atmospheric composition reveals a world where life as we understand it could hardly take a breath, let alone thrive. Then, there's the matter of Jupiter's intense gravity. Imagine being pulled in so fiercely that it feels like your very molecules are being stretched. Jupiter's gravitational force is about 2.5 times that of Earth's. This immense force not only affects the gaseous planet's shape, causing it to bulge at the equator, but also would make any theoretical descent a rapid and irreversible plunge. As we ventured deeper, the pressure became nothing short of crushing. Descending through Jupiter's atmosphere, the pressure increases so drastically that it would compress and heat any earthly material to its breaking point. This increase in pressure is not gradual, but rather like hitting a wall that gets thicker and harder the further you go. And speaking of heat, the extreme temperatures we encountered add another layer of inhospitable conditions. As we descended, the temperature rose dramatically, reaching levels that would melt metals like lead and even iron. This extreme heat, combined with the other factors, paints a clear picture of a planet that is anything but welcoming. Through this thought experiment, we've gained incredible insights into the giant gas planet. The conditions we've described, hostile atmosphere, intense gravity, crushing pressure, and extreme heat, are so far removed from our own that they underscore just how uniquely hospitable Earth is. While falling into Jupiter is purely hypothetical, it highlights the extreme conditions that exist on other planets, reminding us of the uniqueness of Earth.